Deep learning is a subfield of machine learning that focuses on training artificial neural networks. From my diary. Pradeep K. Suri. Author, consultant, mentor, and YouTuber. Deep learning is a subfield of machine learning that focuses on training artificial neural networks to learn and make decisions in a manner similar to the human brain. It is inspired by the structure and function of biological neural networks. In deep learning, neural networks are constructed with multiple layers of interconnected nodes, neurons, known as artificial neurons or perceptrons. These networks are called deep because they consist of numerous hidden layers between the input and output layers, enabling the model to learn complex representations of data. The key characteristics of deep learning include 1. Deep neural networks. Deep learning models are composed of multiple layers of artificial neurons. Each layer receives inputs from the previous layer and performs computations to generate outputs that are passed to the next layer. The layers closer to the input are responsible for capturing low-level features, while deeper layers learn higher-level representations. 2. Representation learning. Deep learning focuses on automatically learning hierarchical representations of data from raw inputs. Instead of relying on explicit feature engineering, deep learning models can learn and extract meaningful features directly from the data, allowing for more effective and automated feature extraction. 3. Training with backpropagation. Deep learning models are trained using the backpropagation algorithm, which adjusts the model's internal parameters, weights and biases, based on the computed errors between predicted outputs and desired outputs. This process iteratively updates the parameters to minimize the error and optimize the model's performance. For large-scale data, deep learning models often require large amounts of labeled data for training. The availability of vast data sets, along with advances in computational power and parallel processing, has contributed to the success and popularity of deep learning. Deep learning has achieved significant breakthroughs in various fields, including computer vision, natural language processing, speech recognition, and reinforcement learning. Examples of deep learning applications include image and object recognition, sentiment analysis, language translation, self-driving cars, virtual assistants, and medical image analysis, among many others. Deep learning models, such as convolutional neural networks, CNNs, for images and recurrent neural networks, RNNs, for sequential data, have demonstrated state-of-the-art performance in several domains. The ability of deep learning models to automatically learn complex patterns and representations from data has made them highly effective in tackling challenging problems and driving advancements in AI research and applications. Here's an example of a deep learning program in Python for a medical test and treatment scenario. Python. Import TensorFlow as TF. Hashtag load and pre-process the medical dataset. Hashtag assuming the dataset is stored in x_train, y_train, x_test, y_test variables. Hashtag pre-process the data, example normalization, resizing, etc. Hashtag build the model architecture. Model equals tf.keras.sequential. tf.keras.layers.conv2d, 32, kernel_size equals 3, activation equals reload, input_shape equals image_width, image_height, number_channels. tf.keras.layers.max pooling 2d, pool_size equals 2. tf.keras.layers.flatten. tf.keras.layers.dense, 128, activation equals reload. tf.keras.layers.dense, number_classes, activation equals softmax. Hashtag compile the model. Model.compile, optimizer equals atom. Loss equals categorical_cross entropy. Metrics equals accuracy. Hashtag train the model. Model.fit, x_train, y_train, epochs equals 10, batch_size equals 32. Hashtag evaluate the model. Test_loss, test_acc equals model.evaluate, x_test, y_test. Print, test loss, test_loss. Print, test accuracy, test_acc. Hashtag make predictions on new data. New_data equals Predictions equals model.predict, new underscore data. In this example, the program assumes that you have a medical dataset containing images and corresponding labels. The dataset is loaded and pre-processed, which may involve operations such as normalization, resizing, or any other relevant pre-processing steps for your specific medical scenario. The model architecture used here is a convolutional neural network, CNN, commonly used for image-based tasks. The model consists of convolutional and pooling layers to extract relevant features, followed by flattening and dense layers for classification. The number of convolutional layers, filters, and dense layers can be adjusted based on your specific problem and data. The model is compiled with an optimizer, loss function, and metrics suitable for your specific task. In this example, categorical cross-entropy is used as the loss function since it is a multi-class classification problem. The model is trained on the pre-processed training data using the fit function, specifying the number of epochs and batch size. After training, the model is evaluated on the test data, and the test loss and accuracy are printed. Finally, the model can be used to make predictions on new data by calling the predict function on the new data. Note that the example provided is a general template, and you will need to customize it based on the specific details and requirements of your medical test and treatment scenario. Note: Python itself is implemented in C programming language. The C-Python implementation, which is the most widely used and the reference implementation of Python, is written in C. C-Python combines the Python language with the C runtime library and provides the Python interpreter that executes Python code. The C-Python interpreter translates Python code into low-level C instructions, which are then executed by the underlying C runtime environment. This combination of Python and C allows for efficient execution of Python programs while providing a high-level programming language for developers. Thank you.